chapter 13. Unlike chapter 12, we will not be using a calculator to help us to find solutions and to find graphs. We're going to be doing much of our work without the use of a calculator. And I'm noticing on the first 7 problems, 8 problems, much of the vocabulary, and I can let you take a look in your book to find those vocabulary terms to match. So let's go down to number 9 through 12, which says to identify the terms and the coefficients. So in number 10, this consists of one term. We call that a monomial. And the coefficient is the number in front of my exponent, sorry, in front of my variable, m to the third. So the coefficient in number 10 is 2. Coefficient is 2. Number 12 is made up of 3 terms. The first term is 10. Second term is negative 3x to the third. And the third term is negative 6x. The coefficient of the first term is 10. And the reason why the coefficient is 10 is we can rewrite 10 as being equal to 10 times x to the 0 power. So we want to remind ourselves x to the 0 power is equal to 1. 1 times 10 is equal to 10. So even though there is no exponent and there's no variable next to the number 10, we just remind ourselves that really it's 10 times x to the 0. So the coefficient of the first term is 10. The coefficient of the second term is negative 3. And the coefficient of the third term is negative 6. In just a minute, we're going to talk about rewriting these polynomials so that they are in descending order. We say that that's standard form. So we'll talk about that in just a moment, and then we'll see how we're going to rewrite that. In the next 4 problems, we have to decide whether the expression is a polynomial or if it is not a polynomial. And if it's not, why is it not a polynomial? So basically what we need to know is that in order for a polynomial to be a polynomial, the exponent on each term must be a whole number. So a whole number. Let's talk about what whole numbers look like. I always write the number 0 in the word whole numbers. So whole numbers are from 0. These are positive integers. So any positive integer and 0 as an exponent qualifies a term or a polynomial to be, an expression to be a polynomial. So we notice in number 14, we do have an exponent that does not qualify. It's not a whole number. So we say, no, this is not a polynomial because the exponent is not a whole number. In number 16, this is a polynomial. You'll notice that all of the exponents are whole numbers. We have 3 as an exponent, 2 as an exponent, and then the exponent here is 0. 0 is a whole number, so yes, this is a polynomial. All right, monomial has 1 term, binomial has 2 terms, a trinomial has 3 terms. So number 18, that would be a monomial since it has 1 term. Number 20, it's a trinomial with 3 terms. The degree of the polynomial is always the largest or the highest exponent. So in number 18, the degree is 2, since my highest exponent is 2. Again, number 20, my degree is 4. 4 is the highest exponent in this trinomial. So here we are talking about the standard form, which means we need to write this in descending order from largest exponent to smallest exponent. So in number 22, my term 4m to the third has the highest exponent, and then negative 9m to the second. And the degree of this polynomial, or the degree of this binomial, is 3, since that's my highest degree. And then finally, I also need to write what type of polynomial it is by the number of terms. So we would say that this is a binomial. it's a binomial because it has two terms. Number 24 is a trinomial. In standard form. And the degree is 2, since 2 is the highest exponent. Then we need to simplify some expressions. And what I notice in number 26 is that we have a -1, a negative that we need to distribute with both terms inside the second set of parentheses. So when I rewrite this, I have 4m squared plus 9m, and as I distribute, 2m squared becomes -2m squared, and positive 6 becomes -6. And then I can add like terms. 4m squared minus 2m squared plus 9m minus 6. Now, number 25 and number 27, you don't need to distribute a negative sign. So in those two, you can just group like terms and add those like terms together. Take a look at number 30. All right, negative 5x squared, negative 10x, positive 9. X cubed, my next highest exponent, negative 5x squared, 10x and negative 10x cancel to 0, and plus 9. In number 32, we need to evaluate the function of h of x when x is at -4. So I need to look up here and to find what my function h of x is defined as. The function h of x is equal to the function of f of x plus the function of g of x. The function f of x is defined as 2x plus 1 together with the function of g of x is defined as x squared plus x minus 3. In standard form and combining like terms, that gives me x squared plus 3x minus 2. So h of -4 is equal to -4 squared plus 3 times -4 minus 2. So h of -4 is equal to 2. So from the previous problem, I've already evaluated the function of h of x as being the sum of f of x and g of x, which was x squared plus 3x minus 2. So if I'm to evaluate at x equals 1, you want me to find what h of 1 is equal to. Okay, we have a review question from first semester, and what I notice is I have some parallel lines, and the reason I know that they are parallel lines is these two symbols. It reminds me those two lines are parallel. So I have a variety of alternating interior angles, alternating exterior angles, corresponding angles, same side interior, same side exterior. What I notice is that they give me these two angles, and I'm thinking what the relationship is between those two angles, and my choices are either they are congruent to each other or they are supplementary to each other. And because they are they are same side exterior angles, the relationship is that they are supplementary. So I do know then that 11x plus 4 together with 5x must equal 180 degrees since they are supplementary angles. So therefore x is equal to 11. So to find the measure of, start with a measure of angle CHF. Angle CHF is this angle right here. So if I know my value for x is equal to 11, then to find the measure of angle CHF is equal to 5 times 11, or 55 degrees. Now, just by knowing that this angle is 55 degrees, I can now determine that this angle that's vertical is 55 degrees. This angle here that corresponds with this angle right here is also 55 degrees. And this angle that's vertical and corresponds to my original angle here, 5x, is also 55 degrees. And so all the other supplementary angles are 125 degrees. So that should help you find the measures of any of the other angles that you're asked for.